Hi everyone. I wanted to make sure to walk you through the lesson for this week, just to help you get started with the beginning of the activity. So the activity is going to be using the gizmo again. You'll have to make sure that you're signed into explorelearning.com and that you've enrolled in the class. Um, you'll have to make sure that you're enrolled in that first in order to see this activity. So you are going to be checking um, these questions in the handout. And the new vocabulary that we may see in this handout is asymptote and exponential function. So do a couple of these questions before you're using this gizmo to explore with exponential functions. So as an example here, it says a student sends a text to 3 friends, then those 3 people each forward the text to 3 of their friends, and we'll call that round 2. Then the round 2 recipients also each forward it to 3 friends, so that's round 3. How many students receive the message in each round of text? So if 3 people ended up sharing that text to 3 other people, each of them, then you should have that round. And then after that, they send that text over to another 3 friends, each of them. Okay. Um, so before you go into the gizmo, as a definition, for an exponential function, you have an initial value, we'll call that a, that's going to be repeatedly multiplied by the same positive factor, which is b. So we have this equation, y equals a times b to the x power. So the variable here is going to be in the exponent this time. And we have seen that before for the past couple of weeks. That's in one of our sequences. So you could say that one of our sequences is an example of an exponential function. So you're going to explore the effects of A and B in this function, and then you're going to just explore with dragging the sliders in here. So if the base is going to be changed, if the value B is changed, notice that here it's starting at 2 here, preset to that, but you can move this around, and it's at the least value in here, it's 0.01, so no less than 0.01. Won't go any further than that. And then for here, it's just going up to +8. Okay, so actually all these values are positive in here. In the case of this equation, b is always going to be a positive factor in here. Okay, so when b is greater than 1, it did change in some way. What happens is it keeps getting greater and greater. And as opposed to that, when you have at 1, there's something else that's happening. And what happens when it becomes less than 1. So please describe in your handout what would happen from there. What point do all the functions of the form y equals b to the x have in common? So you may have noticed that there is a single point here. Even though b is changed all throughout as I move the slider, there is one point that is staying the same here. And I will say right over here. So you might have noticed that it was the point 0, 1. So that's the only point that all of these functions have shared in common with. Okay, so activity A. By the way, I recommend that when you're starting this out, that you are just doing with these 2 activities, um, just focus on completing part A for the first half of the week, and then you can pace yourself, and then you complete activity B for the second half of the week. Okay. So when you're considering this function y equals 2 to the x, it says do not use the gizmo yet, so we won't. Evaluate these expressions. 2 to the 0 power. Anything to the 0 power is going to be equal to 1. 2 to the first power, that is 2, just by itself. When you, as you go up in power, just make sure you're multiplying by 2 every single time. And then for part B, it says the values above give you 6 different points on the graph of y equals 2 to the x. What are they? So you have x is 0 in here, and that's what you evaluate as 2 to the 0 power. So you should have here, for example, 2 comma 1. This one is 2 to the first power for that value of x, where x is 1. So then you would have 1 comma 2, and so on. Okay. you would graph what that looks like over here. If you are printing this out, then you just show it on that paper, or you just show the work on a separate piece of paper. It's your choice of how you want to show your work for completing the work on this handout. And then you can go ahead and see what it looks like on the gizmo, what 2 to the x power looks like. Okay. With negative exponents, so this one has here 2 to the negative third power. 2 to the negative third is the same as 1 over 2 to the third power. So as the example here, 2 to the negative 4, it's 1 over 2 to the positive 4 power. So then that's going to be 1 over 16. And then after that, you can go ahead to write out what the corresponding points are for that graph, for the graph of 2 to the x. So you'll see that you'll have more and more of these points for the graph of y equals 2 to the x, and you can compare your answers over here in this table. I will go ahead and put 2 to the x power here, so I have to set b equal to 2 here. If I click over here in the table, then I should see more of these points here. And what you may have written in your handout would be as a fraction, and that is totally fine. I actually do prefer that because that gives an exact value. Whereas here on this table, you'll just get an approximate. So it is rounded in here, but you are able to check your work still with that. Okay. And then, yes, you should be able to see what it is for what the coordinates are, and that should be the same as what you have on your handout. Okay, make corrections as you need. So this part here where it says y equals 2 to the x, when you have it graphed, it says to select probe. So if you go back to the controls here, there it is to say show probe, and you can drag this green probe over to the left or right. It'll only shift over left or right. So it's just showing this vertical line here that's just trying to show you where exactly they intersect along this curve. So what are the y values as x approaches negative infinity? And we may have seen some sort of notation like this before because we have talked about end behavior in the past. So this is a notation for describing as x approaches negative infinity. So if x is approaching negative infinity, that means that negative infinity for x is going to be going towards the left. So as this is going towards the left, just notice what is going on to the y values in the table. I'm going to start over from the beginning over here where it was. If I look back in this table, it has x 2.9, so that's as far as I'm just trying to put it here. And y is evaluated here, that's the point y here, and the y value is 7.46. But as I move this probe over to the left, that means that x is getting smaller. It's going towards negative infinity. What is happening to y over here? I do see that it is decreasing. But then as I go further and further along over here, it looks like the y values are going just 0.01, 0.01, 0.01, still going like that. And it actually says 0 over here. So actually it's getting closer and closer to 0. And if you actually zoom in some more, notice here that this is still going further along over here. I can keep on going. And it looks like it is getting so close to 0, really close to there. But even if I zoom in some more, I see that I actually still have more to make up for. So it's getting really close to 0, but in actuality, it's never going to approach 0. So what we call that, and it says here in the handout, a line that a graph gets closer and closer to a value, it's called an asymptote. The thing about asymptotes is that it looks like it's getting really close to that value, but in actuality, it's never going to reach that. And what I really love sharing with my classes about asymptotes is that if you think about it, asymptotes is like a sad love story. And I have a great song for you to check out that I'm going to make sure to link to you in Schoology. So take a listen to this. It has a couple of lines that might be familiar to you, some words that are not familiar to you, but I think it's a pretty fun song to listen to and remember what exactly an asymptote is. Okay, so I wanted to just make sure to go over those parts with you, and feel free to ask any question. It is for you to just explore with this. So do whatever you would like to do to explore and understand more about what exactly exponential functions are like.